All right, here are solutions to the first perfect problem for Math 111. What I tell you is we have these exponent rules that we talked about in class, and I'm going to call them Rule 1, 2, and 3, although I don't think that that's anything standard. I think that's just so we can refer to them. And then there's these consequences. These things, you can think about them as more rules, but I didn't want to have 6 rules. And really, these are just consequences of these rules. These have to be true. So I'm going to call these consequences 1, 2, and 3, again, just to keep my lists shorter, I guess. And what I want to do is simplify this thing right here. And there's lots of different ways you can simplify this thing. There's at least 2 different ways involving the rules that we have. And so what I want you to do is do it both ways. I want to show you kind of some of the flexibility and freedom you have when you're doing these. So I talked you through what I want you to do in 1a. Maybe I'll write it up here to save room. I want you to take this thing, x squared times x cubed raised up to the 4th power. And then I want you to apply the first exponent rule. So maybe I'll put a little 1 over here to remind myself that I'm using the first exponent rule. And then later apply the second. So okay, the first exponent rule says that when you're multiplying 2 exponents with the same base, you can add those exponents. So is there anywhere I have, oh yeah, right here inside the parentheses, right? I got 2 exponents with the same base. So I can add those 2 exponents. I can rewrite what's inside the parentheses as x to the 5th power. That gets me here. And now I got x to the 5th to the 4th power. What's it want me to do? Apply the second exponent rule. The second exponent rule says that when you have something, an exponent raised up to another exponent, you multiply together those 2 exponents. Oh, how convenient. That's exactly what I have here. So using the second exponent rule, I would say that this is equal to x to the 20th power, 5 times 4, which is the answer. Right? Nothing too groundbreaking there, but fine, that's one way you can get there. What I find kind of interesting is you can get to that exact same answer using a very different method. So part B here, I say start with the exact same thing, that x squared times x cubed raised up to the 4th power, and hopefully end with the exact same thing, but get there differently, take a different path. First, apply the third exponent rule, and I give you this little hint in reverse. So that's kind of just my wording, but what I'm saying is hopefully you're starting out with something that looks something like this, and you're going to end up with something that looks something like this. And this one's a little bit tricky, because you're like, all right, I see an x in here, but it's squared. Okay, playing the role of x is x squared. Playing the role of y is x cubed. And playing the role of a is this number 4. So really what I have right here is exactly what I have on this side of the equation. And so what I can do is I can rewrite that like it's this side of the equation. So using the third exponent rule, I can say that this is equal to x raised up to the a power. Well, remember my x was x squared. So I got x squared raised up to the a power times y raised up to the a power. Well, again, remember the y was the x cubed. So I got x cubed raised up to the 4th power. So I could apply the third rule to get me from here to here if I wanted to. And then I have some choices, but what I might want to do is apply the second exponent rule twice. The second exponent rule says when you have an exponent to an exponent, you multiply them. Oh, right, I have that here and here twice. So what I can do is say x squared to the 4th power is just x to the 8th power, and x cubed to the 4th power is just x to the 12th power. And then finally apply the first exponent rule that says when you have the same base, you can add the exponents. 8 plus 12 is 20. Note that we got the exact same answer, but our steps were very, very different. That's the point that I'm trying to make in this problem, is that when you're dealing with exponents in our exponent rules, there's lots of different paths to get to the same result. Which sounds like a great thing, but it can actually be a really confusing thing for students, which is the point of this whole problem. So now that I talked you through 2 different ways to solve one problem, what I'm doing here is I'm giving you a second problem, this guy, which is kind of a mess, and asking you to solve it using these 6 facts up here, but in 2 very different ways, or at least 2 like I did here. Okay, so problem 2, I'm starting out with this, I guess I'll just write this start, cubed root of x to the 11th divided by the cubed root of x squared. And that whole thing is squared. And what I want to do is solve this thing using as many different methods as I can, kind of emulating what I did in 1 here. Well, one thing that I could do here is I could apply my second consequence, right? Because I have a radical in here. I have the cubed root of x to some power, so I could rewrite that as a fraction. I could change from radical notation to rational notation. So I guess I'll write that using what a consequence 2? Yeah. I could say that this thing up here is equal to x to the 11/3 divided by x to the 2/3 squared. And then from here, I'd have several different options. One way I could proceed is to apply this third consequence. So I could say consequence 3 allows me to subtract those exponents. Right, so figure out what 11/3 minus 2/3 is equal to. 11/3 minus 2/3 is 9/3. 9/3 is just 3. So I could write this as x cubed to the second power. At which point I have something that rule 2 applies really nicely too. It says when you got an exponent raised up to an exponent, multiply those two numbers and get x to the 6th. So I got an answer. That's good. And then the point that I'm going to try to make is there's lots of different ways I could solve this and get the same answer but with different methods. So instead of starting over from the start, I'm going to be a little bit lazy. I'm going to reuse this and this, but then point out that at this step I could, instead of going down this way, I could have done something different. Let's see, I subtracted these two, but maybe you don't want to subtract those two. Maybe you'd rather deal with negative exponents, for example. Maybe you would rather, you don't want division going on anymore. You want x to the 11/3 times x to the negative 2/3 squared. Wait, how did I do this? I had a division problem, and now I have a multiplication problem with the negative exponent. That is this first consequence here. It says that if you're ever dividing by a number, you can change it into multiplying by that number if you change the exponent from positive to negative. Change the sign on the exponent. So that is the first consequence. Maybe I write that over here. And then what could I do from here? Well, again, you got options. One option would be to, I have the same base in different exponents, so let's add those up. All right, 11/3 plus negative 2/3. 11/3 plus negative 2/3 is 9/3. 9/3 is 3. So I could get x cubed squared. And that is when you rule 1, I guess. And then after I apply rule 1, I can stare at this thing and say, exponent raised up to an exponent. My second rule allows me to multiply those two and get x to the 6th power. So there's two different methods. I think the problem only asked for two, but I'm going to show you more ways you could do this if you were so inclined. At this step right here, if I didn't want to apply rule 1 and add those together, what I could instead do is apply rule 3 in reverse if you want. I could rewrite this as, maybe I'll write it over here, rule 3. I could take this 2 and sort of distribute it down. So I get x to the 11/3 squared times x to the negative 2/3 squared. And then, kind of like I did above here, I could apply rule 2 and then rule 1. Rule 2 would tell me that that right there is equal to x to the 22/3 times x to the negative 4/3, because I take 2 times 11/3 and get 22/3, and 2 times negative 2/3 and get 4/3. And now I got an exponent times an exponent. I got the same base. I can add up those exponents using my first rule. It says that that's equal to whatever 22/3 plus negative 4/3 is. I guess that's 18/3, but 18/3 is just 6. So you get x to the 6th power. So there's a couple ways, I guess 3 ways you could do this. There's lots of different ways you could do this if you were so inclined. Maybe people will get creative and find lots of different ways. Maybe I'll even write that lots of other possibilities. I should have started this by writing, maybe in green over here, your answers may vary. But hopefully I've done enough to kind of give you an idea of different ways you can solve this, and you can kind of go from there. Make sure you're getting the same answer. I'll end this video here.